My name is Liang Huang, and I'm principal scientist at Baidu Research in Sunnyvale, California, and I'm also an assistant professor of computer science at Oregon State University. But this work is about work that I've been doing at Baidu Research.
Tell me a little bit about that research.
So the topic is simultaneous translation, and this is kind of one of the most difficult problems in AI. Simultaneous translation is different from general translation. It has a time pressure. So general machine translation, you can do it in any time you want. You can take 5 minutes to translate a sentence. You can take 10 seconds to translate a sentence. That's up to you. But in simultaneous translation, you have to go in sync with the speaker. That is to say, you cannot delay too much, and your translation has to be happening around the same time in a real-time sense with the original speech. So you might have heard of other companies' work, for example, Skype translation, which they claim can do real-time translation, but it's real-time but not simultaneous in the sense that you would speak a sentence in, say, English, and then Skype would translate it into, say, German, and then the German speaker would respond in German, and the Skype translator would translate back to English. The time it takes is doubled in this mode. You have to do it consecutively, and you have to wait until a sentence is finished before you can translate it. So we call that consecutive interpretation or consecutive translation. And this is often done in the United Nations, and the United Nations hire a lot of such simultaneous interpreters, human interpreters, to perform this simultaneous translation every day in New York, in Geneva, United Nations. Yeah, so this is what we're trying to automate, that is simultaneous translation.
Roughly speaking, how many people as a career do simultaneous translation at that level?
Because simultaneous interpretation is extremely difficult for human beings mentally, it's extremely challenging to kind of concurrently comprehend one language in headset and also speak in another language. It is reported that only 2,000 or 3,000 qualified simultaneous interpreters can actually do this job worldwide. It's just so difficult that each qualified interpreter can only sustain for about 10 minutes, after which you'd have to switch off, and they work in pairs or groups of 3 because each person can only sustain for very limited amount of time, like 10 minutes. There was a study actually that after just a minutes of translation, their error rates grow exponentially. The interpreter is too tired just after a few
fascinating.
minutes. Yeah, and the best interpreters in the world can only cover about 60% of the source material. This is a well-established number because they have to strategically drop the other about 40% in order to keep up with the speaker. If they try to translate every single bit of the information that the speaker says, then they often runs behind too much and lags behind more and more, and that would render the user or the audience kind of out of sync with the speaker. So they strategically choose to cover about 60% of the most important material. Yeah, this is again due to limited capacity of human memory.
Yeah, so we've gone over some of the reasons why this is a very hard task for a human being to do. Are there any uniquely machine challenges that make it difficult for machine learning to do simultaneous translation?
The main challenge for machines to do so is the word order difference between languages. So consider you're translating from German to English. And as many of you know, German is kind of weird in its word order for an English speaker. So it has subject, object, verb. Like verb is at the end, the verb final behavior in the embedded clauses. And in the main clauses, it's verb second. Linguistically, German is classified as underlyingly SOV. So it's like intrinsically, fundamentally, still subject, object, verb. More like Japanese. Japanese is fundamentally SOV or subject, object, verb. The verb is always at the end. German is mostly like that. And Chinese is also kind of a weird mix of SVO and SOV, that sometimes Chinese verb is like English in the second place. Sometimes it's at the very end like German or Japanese. So there's a famous joke in the United Nations and European Union. Whenever a German speaker starts to speak, the interpreter would often pause and do nothing for like 10 seconds or more. And when you ask him, like, why you're not translating? And he would say, oh, I'm waiting for the German verb. It hasn't arrived yet. So this is well-known challenge for machines to do simultaneous translation.
So if I understand correctly, when we were at NeurIPS together, this is when Baidu was making a big announcement. Is that correct?
Baidu made this announcement about 2 months ago in late October and early November also, so that we announced this breakthrough in simultaneous translation in our Baidu Research Twitter and Baidu Research blog. And then on November the 1st, we had a Baidu World Conference where the CEO and founder Robin Li spoke about the progress of Baidu in AI and other fields. During that meeting, all his speech, Robin's speech, was translated simultaneously using our new technology. As Robin speaks, the Chinese subtitle or Chinese transcription is happening simultaneously, but also the English translation is also happening simultaneously and without much noticeable delay. The delay is about 3 seconds. Again, it's more like a human interpreter would do.
Very neat. What are some of the key things that make this model possible in sort of its deep learning construction?
Previously, it was difficult because the machines cannot handle what order difference. My breakthrough comes, or the eureka moment comes when I said, what if you do not want to wait for the German verb, which comes at the very end? What can you do? It turns out that I know the human simultaneous interpreters employ a special strategy in this case, which they call anticipation. That is, you go ahead of the speaker. You anticipate or predict what they're going to say in about 5 seconds or so, like in the future. In the case of Bush president in Moscow with Russian President Putin meet, after you heard Bush president in Moscow, just the first 4 Chinese words, you can totally guess that it's very likely that the verb would be meet. Because what can he do? Like, what can a president of the United States do in Moscow? In the training data that we have, which is mostly Newswire, it's like 99% chance that he's going to meet with somebody, likely the Russian President Putin. So given a lot of training data, you can actually train a model to anticipate or to guess not just a verb, but anything, any word ahead of time, so that you eliminate the need to wait or pause for a very long time. Technically, the key idea is called a prefix to prefix model. So it's kind of like a sequence to sequence model where everybody uses, in not just translation, but all kinds of other things as well. We cannot have the full sequence because we do not want to wait to the end of the source sentence. We want to start the translation as soon as possible. So our idea is to only have the prefix, and then you force, during training time, during deep learning training time, you force the model to predict the target side prefix given the source side prefix. At each time step, we only have a growing prefix of the source sentence that is incrementally revealed to us one word at a time, not like the full sentence, the full sequence. The target side, of course, is also generated incrementally, that is one word at a time. We call this weight K model or a prefix to prefix model, where you would wait for the first K Chinese words or source side word, and then you would translate one by one. One Chinese word in, one English word out, one Chinese word in, one English word out, so that the user does not feel a delay, right? The user only feels a delay at the beginning. After about 3 seconds into the speech, this translation starts, and then it grows at the same speed with the source language speech. So this is very much like, again, human interpreters. They would kind of wait for about 3 seconds into the speech, and then they start to translate. And this wait K provides some context for guessing. If you wait too little, like if you wait one word, then probably you cannot guess the right word.
Yeah, that makes a lot of intuitive sense. Today's podcast is supported by the University of San Francisco. At USF, you can study the new digital economy from its ground zero, surrounded by the firms that built it and the startups that will create the next revolution. The University of San Francisco's new Masters in Applied Economics is a STEM-designated program that combines economics training with the practical skills and data analytics needed to understand the new digital economy. Study the economics of platforms, auctions, pricing, reputation, and business strategy, at the same time as you learn the tools of econometrics, causal influence, experimental design, and machine learning using R and Python. To learn more and get your application fee waiver, go to usfca.edu/skeptic. That's usfca.edu/skeptic. When you go out to construct your machine learning process, do you have to set up the architecture or add in some ensemble learning to kind of take those intuitions you shared and make them a part of the system? Or are those behaviors that emerge out of a well-constructed deep neural network?
So this is again a sequence to sequence, a variation of sequence to sequence model, which we call a prefix to prefix model, right? So the training time is different from sequence to sequence, but kind of inspired by sequence to sequence.
Mm-hmm.
It's actually very easy to do. So based on any existing sequence to sequence framework or code base, you can just hack our idea onto it with very minor changes. So even though the model looks quite different, and that difference is actually kind of hard to come up with, but once you come up with the idea, the actual change in the code base is actually relatively minor. And so that's another surprising feature of this work, that it actually is very very easy to do once you had the idea. It's just the idea itself is very hard to come up with.
Yeah, interesting. And what sort of data set do you do your training on? How big does it need to be, and what's sort of the nature of the data?
So you normally would think that you would need to train on some special simultaneous translation data set, which is different from normal machine translation data set. But actually, we don't have those specialized data sets. So we can only use the normal classical machine translation data set, which is mostly Newswire. The data set is just the same as those we train a normal machine translation system, that is many sentence pairs, one English sentence, one Chinese sentence, one English sentence, one Chinese sentence. They're called parallel sentences. And we have like 1 million or 2 million, actually 2 million of those Chinese English sentence pairs. So this number varies for different language pairs. For example, for German English, we have a little bit more data, but for Chinese English data set, the experiments that we do in this paper, we only used 2 million sentence pairs, which is okay, which is kind of a okay number. Even if you have only 1 million, that's fine. You only need the same data set that you normally use for machine translation. Just use it in a different way when you train your system. So normally you would use the full source sentence, the full sequence, and then you try to force it to predict the target sentence. That's how you train a normal machine translation system. In our case, you would use the same set of data, but treat each sentence as a growing prefix. So you first use the first two words to force it to predict the first English word, then first three Chinese words to predict the second English word, and so on. So you just use the same data, same old data, in a new and creative way.
So it seems to me there's one parameter you have here in doing simultaneous translation. There's, how much you wait versus how much you try and predict. Is that a way in which you frame the problem? And if so, do you know anything about, the changes to accuracy or whatever diagnostic you're looking at as you give more or less wait time for the translation system to kind of see into the future a bit?
There's a trade-off between latency and quality, right? So if you wait longer, of course you can predict better and you can translate better. The user would prefer, of course, low latency and high quality, but there's always a trade-off. If you do low latency, then the quality likely would suffer a little bit. There's a example sentence, which says, Jiang Zemin, which is the previous Chinese president, to French presidents to China visit, express gratitude. And in a weight 3 model, first 3 words, you would start translating after you hear the first 3 Chinese words, which is Jiang Zemin to. And then you would start to do a word by word translation, which is Jiang Zemin expressed his appreciation for the visit by French president. And in this case, the weight 3 model would work okay. What if, which is unlikely, but what if the last Chinese word instead of gratitude is actually regret? Uh-huh. That's, so maybe not Jiang Zemin to French president's visit, but Jiang Zemin to French president's remarks or statement express regret. And then our system would make a mistake if you wait just 3 words. But if you wait just 2 more words, that is, wait 5 words, then you have enough time to hear the last word regret before you translate that word. So in that case, you have more latency, which is bad, but you avoid the mistake of express gratitude or express regret. You just have enough context to see the word regret. So there's always a trade-off. And human interpreters do make mistakes in anticipation and prediction. Mm-hmm. In case of like a sentiment, kind of yes or no, or kind of positive, negative mistake, which is that big, then the human interpreters would often have to say, I'm sorry, I made a mistake, blah, blah, I retranslate, right? If it's not that much a mistake, then they would just go on. Technically speaking, gratitude and appreciation are not the same word, right? So the Chinese sentence says, express gratitude. In anticipation, we translate it into express his appreciation. But that's fine. That's totally fine. So in this case, human interpreters don't need to make a correction. So we are working on the next version of this system, which has an ability to detect and correct kind of critical mistakes like this, even though the critical mistakes are not very likely. In the current version of our system, we do not have a way to detect and correct these mistakes. Yeah, that's something we will release in the next version. But we do have a very easy way to do that, to detect the mistakes and correct mistakes.
Can you share anything about maybe some empirical diagnostics on I don't know if accuracy is appropriate for the system or if it's F1 score? How do you measure the quality of your work?
We use a blue score, which is a metric for translation quality. So this blue score, again, is based on full sentence translation. That is a string level similarity between your machine's output, your machine translation, and a human translation, which we call reference translation. For the same Chinese sentence, we just hire a human being to translate into English, who is, of course, a bilingual speaker, to translate into English, and then we compare the human reference with our translation, and the higher the blue score, the better. Meaning, like if the blue score is 100, it means you have the identical translation with the human translation. But of course, you cannot get 100% because one given Chinese sentence, there are a lot of different ways to translate it into English, right? So translation is unlike a classification problem, does not have a unique right answer. For a given sentence, there are often like tens or dozens of correct translations. Even human-to-human translation, blue score metric would be like about 60% or even lower, just because they're just not a unique answer, right? Because we're doing simultaneous translation, we do suffer in quality when you have a smaller weight three words model, right? So in this case, the weight three words model is about 4 points worse than full sentence translation. So full sentence translation, you have to wait to the end of a whole sentence, which is bad in latency. And if you do our simultaneous translation with only 3 words delay, which is about 1.2 to 2 seconds, you get about 4 blue points less in quality. And if you wait 5 words or about 3 seconds delay, it's about 3.4 blue scores less than full sentence translation. So this is the cost that you have to pay if you want to do simultaneous translation, right? So it's not like our score is worse than the baseline, meaning like we are bad. No, it means that this is some cost, some trade-off between quality and latency. And we think that number could be, reduced a little bit further, but it will not be zero, right? It will not be zero difference. Yes, yeah.
Well, your work does seem like a major step forward in translation in general. With that in mind, can you tell me a little bit about where are the frontiers in translation? What are the breakthroughs left to be done, and what's interesting things you're looking forward to putting research time into?
This is a special scenario in translation, right? So it's not like general translation where there's no time constraint. I would not say this is a kind of major improvement in translation, because translation is very broad, right? So there are a lot of different scenarios of translation. We are only targeting at simultaneous translation, right? So we think that simultaneous translation is very user friendly. So just the comparison between consecutive translation and simultaneous translation, if you use our current Baidu Translate app or Google Translate app or whatever Translate app to conduct a conversation, say in Japanese when you travel to Japan, and if you don't speak Japanese, and you would say something to your phone in English, and the phone would translate that to Japanese, and then the Japanese person will respond in Japanese, and the phone translate back to English. It would cost you twice as much time as you could do in one language, right? So if you want to order something, it might only take you, or like you would book a ticket or check into a hotel, which you would take only like say 2 minutes to do if you can speak English to that person, but that would take about 4 minutes, right? Twice as much time, and that would often make the user frustrated because I was not accustomed to like this kind of conversation taking twice as much time. But if you have simultaneous translation, the other side of your conversation can see or hear the result simultaneously as you speak. So it's only about 3 seconds delay. And also, we have a use case in a conference setting. If you take your Baidu Translate app, and if the next version of Baidu Translate app certainly kind of support this simultaneous translation feature, which we're working on right now. You can just look at your iPhone screen, or you can just listen to your phone when the conference is totally in German, and if you don't understand German, and you can just see the English translation kind of simultaneously and in sync with the speaker. And in general, I think translation is a great thing, that it breaks the barrier between people. It breaks the barrier between cultures, between countries. And simultaneous translation would just further make it even more smooth, because you don't even lost the time, right? So you don't even need to take twice as much time to do so. There's a a joke that using translation, you can pretty much, in the current technology of translation, you can achieve a lot of things. But the current technology cannot let people speaking different languages date each other. But we think that with a simultaneous translation tool, it's possible to date another person who speaks a totally different language which you don't know. Yes, that would be fantastic. But it's just goes all the way to the extreme of breaking down the barriers between human beings and between cultures and between languages and between countries. So that's our ultimate goal in this research. But of course, towards that step, there's one piece that is missing. Currently, we only do speech-to-text translation, right? So in other words, we only saw the subtitles or the translated subtitles. Human beings do prefer if they can listen to the headset. Just like if you watch a movie from other countries, you have two options. One, sometimes it's just subtitle translation, but you would still prefer if the conversations are already translated into English speech, right? So then you can just listen to the headset. We're working on that, but we don't have a good solution for that yet. So that's again very challenging. And to read it out, you have to be fluent in English prosody, right? You cannot be like like you cannot sound like robotic. You have to sound like a real human being. This is called text-to-speech synthesis, or TTS. The current TTS technology still relies on the whole sentence in order to be very fluent. If you give it the whole sentence, then it knows where to rise the tone, where to drop the tone, where to do the emphasis, where to take a slightly longer pause and stuff like that. But if you only review each word one by one, like in a very incremental way, then it poses new challenges again to the TTS system. So again, this is a kind of an active research direction that we are pursuing, in the hope that next year in the Baidu World Conference, we can launch a speech-to-speech, simultaneous speech-to-speech translation system, not just speech-to-text. And then non-Chinese speakers could just listen to the headset while our speech CEO, Robin, speaks. That would be fantastic.
Wow, yeah, I'll certainly be keeping my eyes out to see if that happens. Very exciting.
Right, we cannot promise that we will deliver by that date, but it's our goal. Our technology is not intended to totally replace the human interpreters. We try to reduce their burdens because, as I said, there are only 2,000 or 3,000 qualified simultaneous interpreters worldwide, and there's a huge demand in simultaneous translation because there are a lot of international conferences, more and more like international summits, and a lot of those conferences wanted to provide simultaneous translation or simultaneous interpretation, but there's just not enough supply. We are not intended to replace human interpreters. We think that their service will still be needed in a lot of situations where you require like very accurate translations, let's say between the two presidents, for example, one-on-one meeting between two presidents. And a lot of situations will still rely on human interpreters. So we're not intended to kind of fully replace them.
Well, Liang, thanks again for coming on the show and sharing all your expertise.
Thank you so much. My pleasure.